Hello, welcome back. We're talking about Chapter 4, Proportional Relationships, focusing on Lesson 6, Scale Drawings and Scale Models. The dimensions of a scale model or scale drawing are related to the actual dimensions by a scale factor. The scale factor is a ratio, and remember the ratio is a fraction, right? That's how we're going to be representing it. So if we look here, the length of a model car is 9 inches. The length of the actual car is 162 inches. Well, if we go ahead and try to make this 9 into a 1, the only way we can do that is by dividing it by 9. So 9 divided by 9 is 1, right? And whatever we do to the top, we have to do to the bottom. So we divide both the top and the bottom by 9. What we end up is with 1/18. So what that means is that 9 over 162 can be simplified to 1/18. And this 1/18, what that is called the scale factor. That means that for every inch, the model car the actual car is 18 inches. So that's the scale factor. That's what that means. So whenever you're dealing with this and you're trying to determine what the scale factor is, you're going to put the model or the mini version on top of the fraction. You're going to put the actual thing on the bottom, and then you're going to divide to get a 1 on top. So whatever this number is, you're going to divide it by this number. So there's a 9, so we're going to divide it by 9 to the top and the bottom, and then we end up with 1/18, and that is our scale factor. Okay? So moving on, if you know the scale factor, you can use a proportion to find the dimensions of an actual object or of a scale model or drawing. So here, this states that the scale factor of a model train set is 1/87, okay? A piece of track in the model train set is 8 inches long. What is the actual length of the track? So this 1/87, the 1 is the model length, the 87 is the actual length. So here we have model length on top, actual length on the bottom. So when it says a piece of track in the model train set is 8 inches long, well, 8 is referring to the model train, so it goes on top with the model length. And what is the actual length of the track? So we don't know the actual length, so that is the X right there. So that's how we set up our proportion, because we have our scale factor, which is 1/87. 1 is the model length. So all of this information on top is the model length. Everything on the bottom is the actual length. And so right here, we have our proportion. 8/x equals 1/87. So let's go ahead and figure out what is the actual. If we have 8 inches of model train track, what is that in the actual train track? So here's our proportion. The only problem with this proportion is we need to figure out what X is, but X is on the bottom, and when X is on the bottom, we can never figure it out what it is. So we're going to have to invert this entire proportion. So whatever's on the bottom, I'm going to put it on the top. So it's going to be X equals 87, okay? And then whatever's on the top, I'm going to put on the bottom. So X/8 equals 87/1. Perfect. So now I'm just going to go ahead and get X by itself to determine what X is. So I'm going to, right now we have X divided by 8. I have to do the inverse operation of division, which would be multiplication. I'm going to multiply both sides by 8. Okay. This is 8/1. These cancel out. I'm left with X equals, and then I just need to determine what 87 times 8 is. 8 times 7 is 56. Write the 6, carry the 5. 8 times 8 is 64, plus 5 is 69. And this is 8/1, so then if I multiply the bottom, it would just be 1. So the answer is just 696. Okay? So that's the actual length of the track, is 696. All right, perfect. Awesome. So let's go ahead and move on to the bottom one. Here, it says the distance between two cities on a map is 4.5 centimeters. The map scale is 1 centimeter to 40 miles. So we have the distance on the map, which is the model, over the actual distance, okay? And you can see our scale factor right here. So the distance on the map is 1 centimeter. Actual distance is 40 miles, okay? So that's our scale factor, and we're going to set up our proportion because we have the distance on the map, which is 4.5, and that goes on the top with the distance on the map information. We don't know the actual distance, so that is our x. So we're going to go ahead and figure out this proportion. We got to figure out what x is. The only problem with this is our proportion right here. The problem is that x is on the bottom. So we are going to have to invert this proportion. So everything on the bottom is going to have to go to the top. So it's actually going to be x equals 40, and everything that's on the bottom is going to have to go, on the top is going to have to go to the bottom. This 4.5 is going to have to go on the bottom, and this 1 is going to have to go on the bottom. So now I'm just trying to figure out what x is, and I can now. We have x divided by 4.5, so we have to do the inverse operation of division, which would be multiplication. We're going to multiply both sides by 4.5. Those 4.5s cancel out and become 1. We're left with x equals, and this is 44.5 over 1. We can't really cross cancel, so we just have to multiply across. So I'm just going to have to figure out what 4.5 times 40 is. Okay, so 0 times everything is just going to be 0. So I'm just going to move here. 4 times 5 is 20. Write the 0, carry the 2. 4 times 4 is 16, plus 2 is 18. Since I'm multiplying decimals, I have to have the same amount of decimals in the answer. So there's 1 decimal here, so there's going to need to be 1 decimal there, which means my decimal place goes right here, 180. So 40 times 4.5 is actually 180. Okay, 1 times 1 is just 1, so we can just leave it as that. So the actual distance ends up being 180 miles. All right, pretty cool. Okay, let's go ahead and flip the page, and let's go ahead and look at some other examples of problems. So let's look at 1 and 2. We have a photograph which has a height of 3, and a painting which has a height of a photograph has a height of 3 inches. The painting has a height of 24 inches. So we need to identify the scale factor. So that's what we're doing. So we're going to put the smaller one on top. So the smaller thing is the photo height, okay? So that's going on top. So our 3 inches goes on top. And then we have the painting height, which goes on the bottom, which is 24. So to figure out the scale factor, we need this to equal a 1. So I'm going to go down here. I have 3 divided by 24. And to make this on top into a 1, that means I'm going to have to divide it by 3. Whatever I do to the top, I have to do to the bottom. And 3 divided by 3 is going to be 1 over 24 divided by 3 is going to be 8. So that means my scale factor is going to be 1 inch to 1 inch. So for every 1 inch that the photo height is, the painting height will be 8 inches. So that's the scale factor. Okay, let's look at number 2. We have a butterfly's wingspan, which is 20 centimeters, and we have a silk butterfly wingspan, which is 4 centimeters. So we're going to have the smaller number on top, which is the silk butterfly, over the bigger one, which is the just the regular butterfly. So the silk butterfly would be 4 centimeters, so we put that on top. Butterfly is 20 centimeters, so we put that on the bottom. And to find the scale factor, we need the number on top to be 1. So I'm just going to go down here, 4 over 20. To get the number on top to be 1, I need to divide this by 4. Whatever I do to the top, I have to do to the bottom. So 4 divided by 4 is 1. 20 divided by 4 is 5. And so it is going to be 1 centimeter over 5 centimeters. That is the scale factor right there. Okay, so that's how the scale factor works. Let's go down to problems 3 and 4. So it says on a scale drawing, the scale factor is 1/12. A plum tree is 7 inches tall on the scale drawing. What is the actual height of the tree? So what we have on problem number 3 is we have a scale drawing and we have the actual height. Okay? So the scale factor means that our scale drawing is going to be 1/12. Okay, and that's going to be equal to, it says a plum tree is 7 inches on the scale drawing. So since it's referring to the scale drawing is on the top of the fraction. So 7's going to have to go there, and we don't know the actual height, so that's going to be our x. So there's our proportion right there. Boom. So we just need to solve it and figure out what x is. The only problem is that x is on the bottom, and we can never figure it out when x is on the bottom. So we're going to have to invert this proportion. So everything on the bottom is going to have to go to the top, and everything on the top is going to have to go to the bottom. So let's just go ahead and flip it now. The 1's going to flip down to the bottom. The 7's going to flip down to the bottom. And boom, there we have it. Now we can solve and figure out what x is. So right now I have x divided by 7. I want to get x by itself, so I have to do the inverse operation of division, which would be multiplication to both sides. These 7's cancel and become 1. 1 times x is just x. So now we have x by itself, which is exactly what we need. Perfect. And then we just need to do this. We would try to cross cancel, but we can't. So we're just going to go 7 times 12. I'm going to do that off to the side. 12 times 7, 7 times 2 is 14, write the 4, carry the 1. 7 times 1 is 7, plus 1 is 84. So we have 84, and then 1 times 1 is just 1, so 84 over 1 is the same thing as 1. So there we have it. The actual height of the tree is 84. Boom. So that's how you do number 3. Let's go ahead and try to figure out number 4. It says on a road map, the distance between 2 cities is 2.5 inches. The map scale is 1 inch to 30 miles. What is the actual distance between the cities? So what we have is we have the map scale over the actual distance. And that's going to equal our scale factor. The map scale is 1/30. So for every inch, it goes 30 miles. Okay, and that's going to equal, so it says the distance between 2 cities on a road map. So we're talking about the map. The distance between the 2 cities is 2.5 inches. So that 2.5 inches goes on the top with the max map scale information. So 2.5 is going to go here. We want to know the actual distance. That's what we don't know. It says, what is the actual distance between the cities? That's going to be x. So we have our proportion right here. Boom. Now, on our proportion, we don't know what x is. We need to figure it out. The only problem is that x is on the bottom. And when x is on the bottom, we can never figure out what x is. So we're going to have to invert this proportion. So everything that's on the bottom is going to go to the top. So we're going to have 30 equals x, and then whatever's on the top is going to go to the bottom, 2.5. Boom. So now we can figure x is on the top. We can figure out what it is. We need to get x by itself. Right now, it is divided by 2.5, so we have to do the inverse operation of division, which would be multiplication. We're going to multiply both sides by 2.5. These 2.5s cancel out and become 1. 1 times x is x. We have x by itself. Woohoo! Now we just need to go 2.5 times 30. So I'm going to go 2.5 times 30 here. I'm just going to put 0 times all that is just 0. So I'm going to start here. 3 times 5 is 15. Write the 5, carry the 1. 3 times 2 is 6, plus 1 is 7. I'm multiplying decimals, so I have to have the same number of decimal places. So this has 1 decimal place. That means this has to have 1 decimal place, which means my decimal place goes right there. And so it's going to be 75, and this would be 2.5 over 1. 1 times 1 is just 1, and 75 over 1 would be the same thing. So that means that x equals 75. So the distance between the cities would be 75, and we're talking in miles, so 75 miles. Perfect. So we will see you next time. Bye-bye.